Alright, so woke up today still sick, so we're going to bang out some easy ones today. So, because my brain is not working as well. That's okay. So we got valid parentheses, number 20. Given a string S containing just the characters open, close, open, close, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. Yeah. Okay, so that makes sense. I do wish that they gave an example of nesting brackets because that should be kind of like, this problem would be really easy if that wasn't the case. But per the rules, it is. So yeah. So for example, you can do like that would be like something like this. That would be valid. All right. So let's get into it. So we essentially have to just the only time that something can go wrong in this is when we close a bracket, because when we close a bracket we have to make sure that it's the right bracket being closed. That's the only way something can go wrong. And then at the end, we just have to make sure that every open bracket has been closed. So this feels like a good option for like a pseudo sort of stack. Stack being last in, first out. So we're essentially going to make a little stack of open brackets. And then for every time that you close a bracket, you check if it's the item at the top of the stack. So you say like, hey, well, this is a closed bracket. Can it match this? Well, does it match the last one right here? And if it does, then you're okay, and you remove that from the stack. And then you should be able to move on from there. All right, that makes sense. So since we're just working with a string here, the stack will just be, let's see, we'll just call it opening stack. That's just going to be an empty string. That's going to handle all of the opening brackets. And then as we as we add on for every open bracket we get, we stitch it onto the stack. We also need to come up with a way to represent the relationship between the open and closed brackets. So this seems like a good option for something like a dictionary or like a map, because we can say, okay, for every opening, this is their closing. Or actually, I think a better option would be the keys being the closed brackets, because and when we encounter a closed bracket, we want to use that key to access the dictionary to find what the opening bracket should be. I mean, I don't. I guess it doesn't really matter. Either of them could work, but to me, this just makes the most intuitive sense. So we're gonna say bracket pairs. So this one matches this one. All right, makes sense. Those are the only three pairs. I am grateful for this problem not really including that many edge cases. It's rather nice of them. I guess that's why part of why it's an easy problem. Okay, so now we're just going to iterate through all the characters in the string. So for C and S. Now there's three possible things we had to consider. Okay, so if it's an opening bracket, we don't really have to check anything. We just have to make sure that we add it to the stack. If it's a closing bracket, we need to make sure that it matches its buddy for the closing stack, or for the opening stack. All right, and if it doesn't, well, if it does, then we update the stack. And if it does not, then we return false because there's something wrong. So for example, let's say we had like bang, bang, you know, those we get open parentheses, open square brace, open curly brace. If we get a closing one, if it's anything but the curly brace, it's not valid, because you can't have something like that. I'll make the code a little bit bigger. Cool. So let's code that. So we have the opening. How do we check that it's an opening bracket? Well, since we have the dictionary, we can just use the values. I think it's dot values. We can say if C in bracket pairs values. If it is, then we add to the opening stack. We can just use string concatenation. If it's a closing bracket, which would be else, then we check if the pair lines up. So we say if the last character in the opening stack, being the item at the top of the stack, matches the current character. So we say if C, we could say, okay, so we need to get the last character in the opening stack, so we would say opening stack, and to get the last character we can use -1 equals bracket pairs C. This, I always like to kind of call this like gauntlet style code, which is where you go through, you iterate through some list, and if it's ever wrong, then you return false, but if you make it outside that loop, then it must have been true because it survived that long. So actually we're going to check for negatives. But to be honest, usually any time that you encounter, if you do else and then another conditional inside that block, you can usually scrunch that down. So we're actually going to do elif. We can make it positive. So if this happens, so it's either an opening bracket and we update the stack. It's a closing bracket and it matches the top of the stack. Or else, which is it's a closing bracket but it does not match the stack, in which case we can just return false because something's got to be wrong there. So we're going to say opening stack -1 equals bracket pairs C. So for example, if you get a closing bracket, you check to see, you get bracket pairs C, so you take the closing bracket, use that as the key to get this one, and then that better be the same value at the end of this opening stack. All right. So we are going to update the opening stack to remove that pair, since once we find it as a pair, we can kind of just get rid of it because, you know, it's a one-to-one relationship. So we're going to say opening stack equals opening stack. And then to lop off the last character, we can just do this. And what else? Something else we have to do? I don't think so. Okay. So now how do we check to make sure that so my first thought would be just return true, but that's not the case, because what if there's more opening brackets than there are closing brackets? That would mean that there's an opening bracket left without its buddy. So we're going to make sure that the stack is empty by the time we get through this situation. So we're going to say return length of opening stack. Equals 0. We don't need to worry about closing brackets, because if a closing bracket is ever encountered without a matching opening bracket, it will already have returned false right here. All right. So here's what we're going to do. We're going to run it. I know a problem that's going to come up, but we're going to run it anyway. Okay, so it worked for those 3 test cases, but there could be better test cases. This isn't going to work. Yep. String index out of range is the first problem. So you can see right here, we're given just a closing bracket. But since that's the first one, we check the opening stack, but there is no opening stack because there's never even been an opening value. So let's just make sure that there is an opening stack in the same line. We're going to say if opening stack, we're going to check that the length of it is greater than 0. That's just making sure that we can check it at all. And if there is no opening stack, then it's going to return false. And then this is useful because it's going to check from left to right in terms of conditions. We don't have to worry about an index being out of range, because this code won't be reached if this code is not true. Cool. Okay, let's run that. Okay, it worked. Awesome. It's pretty good on memory. Could be better on runtime. And this is interesting. There's one very quick way that we can make this run a lot faster. Since it has to be a successful group of pairs, that means it has to be even. Because for every 1, there has to be 2. Which means that before we do literally anything, we can lop off a lot of the possible runtime by checking to see if it's even. Because if it's not even, meaning that the modulo 2 equals 1, we can just return false right away. And then now, for all the ones that are odd, we already have lopped off those options. Let's run that. Look at that. Way better on runtime. Awesome. So, that's it. Just to recap, check to make sure it's even before you do anything else. Save some time. Make a stack of the opening braces. Make a relationship between the closing and opening braces. If it's open, add it to the stack. If it's closed, add it to, well, if it's closed, remove it from the stack and continue on, provided that it matches. And otherwise, there's got to be something wrong. So you return false, and then at the end, just make sure that the stack is closed. I do have one piece of curiosity, though. I wonder if this would run faster if we use keys instead of values. Okay, it actually runs a lot faster. I wonder if that has to do with some way that the keys are stored. It would kind of make sense. I think so. More to learn there, I guess, about the way that that memory's stored. But yeah, that's something to keep in mind. It might just be a fluke or something. Anyway, that's it. Let me know if you have any questions or anything. Let me know if there's any way I can do these better. Have a good one.